Let's explore how your browser works and what happens behind the scenes when you run JavaScript code on websites. Understanding this will help you learn programming better, especially when we start working with JavaScript in future videos. First, I want to cover what is a browser before we get into what is JavaScript in further detail, and especially since they're connected in a way. And on my screen here, I just want to mention that I have a notes.txt file for just notes as we go through this. We have a script for some examples and an index.html to be able to see all of this in the browser. Now, first, what exactly is a browser? Well, browser essentially is just a software application like Chrome, Firefox, Safari. It lets you visit websites, and inside your browser there are several pieces that work together to be able to load and show these web pages that you see on a day-to-day basis. One of the first things it includes is the JavaScript engine, and that's going to help run JavaScript code to make the pages interactive. You have the web APIs, and these are essentially just extra tools that are going to help JavaScript do things like waiting, talking to the internet, or changing the page. Bonus functionality, you can say. Then we have the rendering engine, and that's going to read the HTML and CSS as you're building a page that you see on your screen. And then finally, another key component is the networking modules. And these networking modules are sending and receiving data between your computer and the internet. So with these four components, that helps make up the browser. And from there, we can start, using and learning about JavaScript. What exactly is JavaScript? Well, JavaScript we talked about in prior videos. It's a programming language that makes the websites interactive. And when you click on a button, something changes, such as a menu opening or a picture changing. That's more than likely JavaScript working in the background. It's going to run right inside your browser. And so that's going to help control how a page looks and behaves. You don't have to wait for stuff to come back. It can, happen in real time. And if stuff does happen and you have to wait, then that's, that's the benefit of JavaScript as well. It can keep running while you're waiting on other things to get received from the server. Now, JavaScript is possible because of that JavaScript engine that I mentioned here. And, JavaScript code, because we can write it, it's written in a way that more humans can understand, but not necessarily something that computers can understand. And so that JavaScript engine here is really beneficial because it's built into the browser, and it's going to be able to parse your code, compile it, and execute it. So by parsing, I mean reading and checking for mistakes. Compiling means turning the instructions into something that the computer can understand. And then execute, running the code and doing what it says. You can think of the JavaScript engine like a translator between your code and the computer. So the JavaScript engine is like a translator between your code and the computer. Now, the engine consists of two parts. So the JavaScript engine has two parts. Has the call stack and the heap. And that lives inside the JavaScript engine's memory. So the call stack helps keep track of what your code is doing right now, especially which function is running. And the heap is where JavaScript stores data like variables and objects. So the stack keeps track of what's happening right now, and the heap is storing that data in memory. You can think of the stack as like a stack of books, and you put a book on top and you remove it. So you put a book on top when you're reading it, and then you take it off when you're finished. In the same way, when you start a function, you're going to remove it when that function finishes. And then the heap is like just a big storage room where you put all your variables and objects. Now, for example, if we look at this first example, this is an object, a variable assigned to a value of object, and that object's going to be stored in the heap so that JavaScript can remember it and it can use it later. And essentially to summarize, you've got the call stack handles actions, so what code runs next, and the heap is just somewhere to hold information, your data. Now, JavaScript alone can't do everything. So JavaScript needs additional help from the browser, and that's where web APIs come in, so this second part here. So in addition to writing JavaScript, you also can take advantage of these web APIs, which are tools built in the browser that let JavaScript do extra things like set timeout, waiting a few seconds before running something, getting data from the internet, such as fetch, and changing the web page by accessing the DOM, or the document object model, that tree structure that organizes all the elements on the page and that JavaScript can reference, the DOM. We can look at some examples here. We have set timeout and get a better understanding of that. So we have a console.log start, we have a set timeout function, and then we have a console.log end. And here we're going to be waiting 2 seconds before displaying this message. Set timeout is a web API function provided by the browser that lets your code wait for some time before running a task. And as I mentioned, it's just essentially just waiting before doing something. JavaScript alone can't pause or sleep. It's always going to run one thing at a time, but set timeout as part of a web API allows you to be able to have that functionality. And so if we go to our console and we can refresh, you'll see start, end, and then waited 2 seconds. So even though set timeout is between start and end, it won't run until the very end. It won't display at the very end. And so let's break down how that actually works. When the code runs, start is going to print right away, and then set timeout is going to tell the browser to wait 2 seconds before running the function inside, which is that console.log within that. The function here with console.log. And then instead of waiting, it's going to print console.log end. And then after those 2 seconds pass, the browser is going to put set timeout, or this data in the callback queue, puts this function in the callback queue, and it waits in the event loop until the stack that we talked about, the stack here, is available to then add that. And then so the event loop waits until the call stack is empty and then moves the waiting function to the call stack to run it, printing waited 2 seconds. And so that's how that works. It's important to note, I want to mention that JavaScript, the set timeout is not part of JavaScript. So JavaScript is the language where you write code in, but JavaScript can't do everything by itself, like waiting or making network requests. The browser, which we've been talking about, the browser gives that extra functionality with web APIs to help JavaScript do these extra things. And set timeout is one of those browser tools where JavaScript understands how to ask the browser to set a timer, but the waiting happens outside the JavaScript engine. Now, I mentioned the event loop that takes place here, and I want to go into it a little bit further. And with JavaScript, as I mentioned, JavaScript runs code one step at a time, but it still needs to handle many things at once, like waiting for the timer, loading data from the internet. And so the event loop is where that comes in. The event loop takes advantage of 2 things. It takes advantage of the call stack and the callback queue. So we can come here. Let's talk about the event loop. And we have the call stack. And we have the callback queue. The call stack is only going to hold functions that are currently running or about to run. So that's synchronous code. So when you run a function, it's going to go to the top of the stack. And if a function calls another function, then it goes on top of that too, and so on and so on. So that stack is building like that stack of books. And then when a function is finished, it's going to remove off the top of the stack. Now the callback queue is where it holds functions that are waiting to run later, such as that setTimeout function that we ran. It's waiting to run later in 2 seconds, or approximately 2 seconds, and once that's finished, then it's going to hop onto that stack. Now setTimeout is coming from those web APIs, and fetch also is coming from those APIs. Is another type of example, and we can see that, and we can show another example before we go into this further. We have fetch here, and what we're doing is we're console.logging, start fetching data. We have fetch to get some data across the internet, and then we're going to show that data. But afterwards, we're going to say end of script. But because we have to wait for that data, it's going to show up afterwards. And so if we come here, and let's get rid of this, comment this out. If we come here, we're seeing start fetching data, end of script, and then the data that we received. And so that's, again, working with both the stack and the callback queue, which are managed by the event loop. The event loop controls, how those two, in a way, work together. And so fetch, like I mentioned, is, this prints first. Fetch is going to start a network request in the browser's web API system, so outside of the call stack. End of script is going to print right away. And, once data is received, that's going to go onto the callback queue, and then the event loop is going to move that from the queue to the stack when the stack is empty. And so that's what we're seeing. And that's how JavaScript is, taking advantage of the benefits of the browser. And so I just want to quickly recap before we wrap up everything we learned today. And, first I want to mention that, the browser has many parts. We talked about that. It has many parts, the engine, the web APIs, all of it working together to load and run websites. JavaScript is then going to run inside the browser, controlled by this JavaScript engine. The call stack is going to track functions running right now. And the heap is storing data like variables and objects. And then web APIs are the tools the browser provides for JavaScript to do things that it can't do on its own, such as timers and networks requests. And the event loop is then going to manage how JavaScript handles those multiple tasks by moving functions between the callback queue and the call stack. And so that's how JavaScript works behind the scenes. Now that you have a better idea of the engine, the call stack, the heap, web APIs, and event loops, you should have a much better understanding of how your code, your JavaScript, is running in the browser. In future videos, we're going to go further in depth with using JavaScript in practical everyday applications, but I just wanted to get you started in understanding how JavaScript is actually working. So thank you so much for watching, and we'll see you in the next one.